Hi, my name is Mr. Thompson, and I just want to say I'm a normal guy, and I want to introduce you to some of my favorite things. This stoplight, Anvil, a cloud-based platform that lets you design apps using nothing but Python, the Raspberry Pi computer, which is super awesome, the Microbit, also super awesome, a few simple circuits, and a solid-state relay. And using those things together, I made this internet-controlled stoplight, my first Internet of Things project. I'm going to step you through the details of this, and even if you've used these kinds of devices before, I hope you learned something new. And even if you've never used any of these kinds of devices before, I'm going to tell you about them from a novice perspective. Alright, so before we get into the nitty-gritty of how this all works, I just want to show you a really quick demonstration. So right now we are in my Anvil app, which was created at the Anvil website, where I can create apps using nothing but Python. And this app is super simple. All it has is a turn on button and a turn off button. And when I hit the turn on button, wait for it, notice the stoplight turns on behind me. And when I hit the turn off button, wait for it, the stoplight turns off. And why I think that's cool is because anybody with this app anywhere in the world can turn on and off my Internet of Things stoplight right here in my workshop. And I want to tell you really quickly basically what's going on behind the scenes, and then we'll get into the details and I'll show you specifically how I did this. So using the Anvil platform to make my little app, my Thompson Anvil stoplight app talks to my Raspberry Pi computer that's connected to the internet. My Raspberry Pi computer, when it gets a signal from the Anvil app, it turns on one of its pins and it talks to my Microbit, which is not a computer, it's just a microcontroller on a board with some sensors, and it's still super cool. When it detects that pin being turned on, the Microbit, which has a radio built into it, sends a radio signal to another Microbit connected to my stoplight. That other Microbit receives the signal, and it turns on a pin that activates a solid-state relay. And a solid-state relay is basically just a switch that can be operated electrically. So when my Microbit turns on one of its pins, that closes the solid-state relay switch, which turns on the light. And that's basically it. And so next I'm going to step you through the specifics of how I set everything up with each one of those devices. And I'm going to try to do it as quickly as I can. The first thing we're going to do is create the app that's going to control our Internet of Things stoplight. So let's start from the Google bar and just type in Anvil.works, which will take us to the Anvil website. I'll click on the site, and then the first thing I'll hit is Start Building. And now you'd be ready to sign in. I will just sign in with Google, and I will next click on Create an App. There's a number of styles here. I'll just use the first one. And this is the design space where we will build our app. This app's going to be super simple. I'm just going to drag a title over, and I'll put some text in the title. I'll call it Stoplight App. The next thing I'm going to do is I'm going to add a couple buttons. And the first button I will call Turn On. And the second button I will call Turn Off. These are the two buttons that will control the Internet of Things stoplight. So if I double click on this button, I can open up the Python code that will be executed when this button is pressed, and I'll just erase where it says pass, and I will insert my Python code here. There's only one command that I need to use, and it is Anvil server.call parentheses, quote, turn underscore on. That will call a function in my Raspberry Pi computer called turn on. Next I'll go to my turn off button, and same thing, I'm going to erase pass and type in Anvil.server.call quote turn underscore off. Once again, in my Raspberry Pi, there will be a program running with a function called turn off. The next thing I'm going to do is just change the name of this app to Stoplight app. There's only one last step, and that is because this app is going to communicate with my Raspberry Pi computer, I need to click on the gear. I need to click on Uplink, which is a way to connect from the Anvil app to my computer. I have to hit the Enable button, and then I'm going to copy this code. So I'll just highlight it and Control C to copy it. And that's it. I've written my Anvil app. When we're done, we'll come back and I'll hit run, and I'll be able to control my light. Okay, so here we are in the Raspberry Pi, and the first thing we're going to do is click on the terminal, and we're going to type in pip install Anvil-uplink, and that's going to put the uplink libraries on our Raspberry Pi. Alright, so the next thing we're going to do is create the Python program that will control our stoplight and communicate with the Anvil app. So I'm going to go to Programming, select Python, and I'm just going to copy the program in place here. It's in the comments below, and I will save it. And here's what this program does. So there's some import statements for the GPIO pins on the Raspberry Pi, the time function sleep, and for the Anvil server. We're creating an object named red and assigning it GPIO pin 4. This is a line that needs to be before every function that's called from the Anvil app. And then our first function is our turn on function. Notice that the name is exactly the same as in the button press code on the Anvil app. Our method we use is on, so we type in red.on with parentheses, and that will turn on GPIO pin 4. And then we have it wait for half a second, and here's the next function to turn it off, which we called turn underscore off. And again, we just use the method off on our object named red to turn off the GPIO pin number 4. Now, the next line below here is where we have the key that we copied when we were creating our Anvil app. And what you'll want to do is you can just erase out the key I have here in the sample code, keep the parentheses, keep the quotes, and then just copy the key that you copied from your Anvil app under Uplink into this spot right here. And the last line here just makes our Python program keep checking the Anvil server forever, so that the program repeats and keeps running. Alright, so that's it on the code for now. The next thing I want to show you is how to create a simple circuit that this code could be operating, and then we'll look at how to extend that out to controlling the stoplight. Before we wire up our Internet of Things stoplight to our Raspberry Pi and control it with our Anvil app, let's talk a little bit about a simple circuit, electricity, and we'll wire up just an LED to start with. So some of the basic terms we talk about when we talk about electricity are voltage, current, and resistance. And there's a nice little illustration on this slide in the lower left that shows the electric current, which are measured in amps, being pushed through a wire by the voltage and being obstructed from moving through the wire by ohm, or the resistance. So the amps are what's actually flowing through the wire. Those are electrons, lots of electrons. And it's a difference in voltage, a potential difference or voltage that compels those electrons to move through the wire. The higher the voltage is, the bigger the push moving those electrons through the wire. The larger the resistance, the more difficult it is for those electrons to get through the wire. So Ohm's law expresses a relationship between those three quantities mathematically. So I represents the current, and Ohm's law says the current is equal to the voltage divided by the resistance. Meaning if the voltage doubles, twice as much current is going to flow through the wire. And if the resistance doubles, only half as much current is going to flow through the wire. So that's basically Ohm's law and just a really quick reminder of the basics of electricity. Another fundamental concept in electricity is that of the circuit. And so in this drawing on the right side, we have a circuit with a battery, an LED, which stands for light emitting diode, and a diode only lets electricity flow in one direction and not the other, a resistor, and the proper resistance for our circuits tend to range from about 200 to about 1,000 ohms, and a switch and a battery. And when the switch is closed, the electricity can flow through the circuit from one side of the battery, through the LED, through the resistor, through the switch, and back to the other side of the battery. Okay, before we move on, I just want us to focus on this basic circuit a little bit more and talk about how it relates to the Raspberry Pi, the Microbit, and the solid-state relay. So first of all, the Microbit and the Raspberry Pi do not turn the light on and off by breaking the connection or the wire in the circuit. Instead, they both use their output pins, which can either be set to 0 volts or 3.3 volts. So it has the same net effect as taking this wire and either connecting it to the negative side of the battery, in which case no light would light up, or making it like the positive side of the battery, which makes the light light up. The other thing I want to mention really quickly is that the solid-state relay really does act like the switch below. And as you'll see in a minute, we wire it into the circuit, but instead of physically turning it on and off, we turn it on and off with the exact same kind of electrical signal that would make this light turn on and off. So it's an electrically operated switch. Okay, so now we're going to wire our LED circuit to the Raspberry Pi. And here's a nice picture showing the Raspberry Pi with the GPIO pins in the same orientation. I'm going to connect my LED circuit to this pin right here, the third pin down on the right, which is one of the ground pins. And then the other side of the circuit, after the electricity goes through the resistor and through the LED, it's going to come back around and it's going to connect to GPIO pin 4, which is the fourth pin down on the left. Here's what my circuit looks like after it's been wired. So here's the electricity connected to the third pin down on the right, which is one of the grounds. It goes through this wire into one side of the LED, the side that has the shorter LED leg and has the top part inside the LED looks like a little upside down L. It goes through into this blue wire, through a resistor to slow down the electricity. This happens to be 220 ohms, and then back to the Raspberry Pi into GPIO pin 4, which is again the fourth pin down on the left. Here I am back at the Anvil website. I want to conduct a test to see if my Internet of Things LED works. So I'll hit the on button and the off again, and it looks good. And this is a point where I want to ask you to use your imagination and to remind you, if you can turn an LED on and off, you can turn just about anything on and off using a solid-state relay. So we're going to keep doing a little more work to make the Internet of Things stoplight work, but I want you to start thinking, what do you want to control with your Internet of Things app? One of the previous slides shows the circuit for a solid-state relay, but I want to show you a solid-state relay physically wired up. So here's a power strip, and this power strip can now be controlled with this solid-state relay. The red wire goes to the output pin on the Raspberry Pi or another device like a Microbit, and the black wire goes to the ground or the 0 volt connection. When the red wire is set high, that is, it's made to go to 3 to 5 volts, then this solid state relay closes and allows electrical power to flow through. So for me to hook this up, what I had to do was I had to cut into this extension cord, and I had to cut apart the white wire here. I then soldered each end that I cut apart into each of these two pins on the solid state relay, the output pins 1 and 2. And I connected a couple wires and soldered them to these input pins. The negative one goes to the ground on my device, and the positive one goes to the output pin that I would otherwise be using to turn an LED on and off. And if I just connect this to my Raspberry Pi in the place of where I had the LED, I would now be able to power my Internet of Things stoplight. So I could just plug the stoplight into this, turn it on, and whenever the LED would have been turning on because this pin went high, the electricity can now flow through the solid state relay and turn on the Internet of Things stoplight. So basically, that's everything we need to create the Internet of Things, whatever you want, whether it's a stoplight or whatever you want to plug into a power strip like this. But I don't really like having to run wires from my Raspberry Pi to where my Internet of Things stoplight is. So that's why I need to show you one more step, how we can use a microbit, rather 2 microbits and their radio link, so that we can untether this wire from the Raspberry Pi and make a better Internet of Things stoplight. Hi, I want to talk a little bit more about the microbit, which we're going to use to create a radio link between the Raspberry Pi and the stoplight, so we don't need to run wires across the room. So I've brought us to the microbit.org website, and here's a quick overview of the microbit. It has inputs and outputs, which are these pins here at the bottom of the microbit. Inputs are used to sense things, and outputs are used to control things. It has a 5x5 LED array that can be used to put little pictures on the screen, or letters or numbers. It has 2 programmable buttons, accelerometers, magnetic sensors, a light sensor, a temperature sensor. It has Bluetooth, and the main thing we're going to be using is the built-in radio. So across the bottom here on this edge connector, it's a little bit awkward to connect wires to this. In this picture it shows alligator clips connecting to the edge connector, but we're going to use something called a breakout board with headers purchased by SparkFun. And I'm going to show you a picture of that right now. Here's a picture of the SparkFun breakout board with headers. The microbit just slides into the black part, and here's a picture showing the microbit connected to the Raspberry Pi. Next thing I want to show you is how we're going to program the microbit, and I want to walk through the program that I used to detect the state of the pin on the Raspberry Pi so I know when to turn on the light and how to send a radio signal to the other microbit connected to the stoplight so that it can turn the stoplight on. To program the Raspberry Pi, I'm going to go to a site called makecode.com, and the Raspberry Pi can be programmed in a number of ways, but this is one easy way to program it. I clicked on the picture of the Raspberry Pi, and now new projects, and I'm going to call my project stoplight app Pi side, so I know it's the one connected to the Raspberry Pi. And this is basically a puzzle piece blocks of code. These are called Java blocks, and there's some things that we're going to have our program do when it first starts, and then some things it's going to do forever. On the left is a simulator showing what programs are doing on the microbit. I'm going to hit this tab to minimize and not show the simulator so we have more space to write our program. The first thing I want to do in my program is to set a radio group. This is just so if I had multiple radio transmissions at the same time, the Raspberry Pi would know which one to listen to, and I just picked 50 for my number. I think it goes from 1 to 99. The next thing I'm going to do is I'm going to create a variable that holds the status of the pin on the Raspberry Pi, and I'm going to call that variable status. And I will start by setting the status to 0. And the last thing I'm going to do on the startup is to set a pull down on pin 0, which we'll all have connected to the Raspberry Pi, and that'll just ensure that unless the Raspberry Pi sets the pin high, that the pin will always read as being low. And so there's a command called set pull pin. Right now, by default, it's set high. I'm going to have it set down so that unless it's being pulled actively high by the Raspberry Pi pin being turned on, it will always read as showing the Raspberry Pi pin being turned off. I'm going to create a function. So I'll hit function and then make function, and I'm going to call my function check status. What this function is going to do is it's going to check the status of the pin connected to the Raspberry Pi. So I'm going to go back to variables, and I'm going to set status now, and then I'm going to go to pins, and I'm going to read pin P0, and I'm going to set whatever the state that I record when I read pin P0 connected to the Raspberry Pi. I'm going to save that state to the variable status. And now in my forever loop, over and over again, I'm going to check status, and I'm going to read pin P0 on the microbit connected to pin 4 on the Raspberry Pi to see whether or not it's turned on or off. Now I'm going to check logic, and I'm going to make some decisions based on whether or not status read as a 0 or a 1. It'll read as a 1 if the Raspberry Pi pin is turned on, and a 0 if the Raspberry Pi pin is turned off. And so I'm going to need a comparative block here. I'm going to go back to variables, and if status is equal to 1, then I am going to send a radio signal, and I'm just going to send a number. In this case, I'll send the number 1 if it's turned on. And I'm just going to right click and duplicate this block. And then if a status is equal to 0, which means that the Raspberry Pi pin was turned off, then I'm going to send a number 4. And that's it. That's my pin checking program for the microbit that's connected to the Raspberry Pi. The next thing I need to do is I need to plug my microbit using a USB cable into my computer. And I need to hit the download button. So I'm hitting download. And this is downloading my program to my computer. And now I'm going to right click on it and show in folder. And here you can see the microbit program I downloaded is in the folder. Since I've plugged in my microbit, I see it as a USB device, and I just drag that program and I drop it on the USB device called Microbit. And so right now it's copying that program into the microbit. You'll notice there's a flashing light here, and it just takes several seconds and it'll be downloaded. And that's it. I have now programmed my microbit. I'm going to plug it in to the Raspberry Pi as I'd shown on a previous slide. And next I'm going to show you how to create the program connected to the stoplight that will receive the radio signal and control the stoplight accordingly. Alright, so we're on our last step. We're going to program the microbit that is connected to the stoplight, receives a radio signal from the microbit connected to the Raspberry Pi, and when it receives that signal, it will turn on or off the stoplight accordingly. So again, we're going to hit New Project, and I'll just give it a name, Stoplight App Light Side, so I know it's the one connected to the stoplight. And in this case, we're not going to need the forever block. And on the start block, once again, we're going to set the radio to group 50 to match the one that we set on the other microbit. And then we're going to go to radio receive number, so that whenever the radio link receives a number, it will do the commands in this block. And I'm going to come down to logic, and I'll use a if-then else statement. I'll need a comparative statement, and I can just drag this radio receive number down, put it in the comparative statement, and if the radio number received is equal to a 1, we're going to tell the light to turn on by setting pin 0 to 1 using a digital write statement. And then I'm going to use another if-then, so I'll go back to logic. And I will go back and pick another comparative statement. Once again, I'll just drag this received number over. If the received number is equal to 4, I'm going to right-click and duplicate this last statement, digital write pin P0, but I'm going to change that 1 to a 0. And that's it for my program that will control the microbit that turns the stoplight on and off when it receives the signal. I'm just going to plug it in, and once again I'll hit the download button. I will right-click and show in folder. And now I'm just going to drag this over and drop it on the device labeled Microbit. And so you can see now it's programming. Almost done. Okay, and that's it. Well, if you've watched this video all the way through, I just want to say thank you, and I'm going to turn on my light again and turn it off again. Notice I've got the response time quite a bit better than it was when we started. I optimized the Microbit program to make it easier to understand, but in so doing it also streamlined it and gave it a better response time. And my next steps are going to be with this little robot. This is a Microbit based robot that I designed for the robotics class at my school. And the robotics teacher wants to do a virtual robotics event where the students drop off their robots at school and then control them from home for some sort of competition. So if I can control a stoplight through an Anvil app, I think the next thing I should be able to do is control these little robots through an Anvil app so that we can have a virtual robotics event at my high school. So thanks again for watching.